All right, yesterday we did this problem at the end of the period. So it was a review, and it's going to be the basis of kind of what we're doing, or part of the basis of what we're doing today. So remember, when we have those rational expressions, we do need a factor. We canceled out factors, and then we stated our restrictions for our denominator, because remember, our denominator cannot equal 0. So we just said x can't equal 3, x can't equal -1. So today what we're going to look at is, if we're looking at equations, how can we figure out our domains based off what the equation looks like, and based off knowing what any restrictions we might have. So with that being said, we're going to start with our examples. All right, so here are some examples that we have, okay? And the directions are saying to find the domain. So for the first one, it just says f of x equals x squared plus 3x minus 17. This is a parabola because it's x squared. So we can do this one of two ways. Knowing that we just finished parent graphs, knowing what a x squared looks like. What does x squared look like? It's a parabola, right? So knowing that if this looks like a parabola and it has arrows on both sides, is there any restriction to what number we can plug in for x? Or what's our domain of that? Does it go left forever and right forever, or is there certain numbers it doesn't happen? It's all real numbers, right? So just knowing what the graph looks like, we can say, oh, well, this is going to be negative infinity to infinity. You can also think to yourself, is there any number that I cannot plug in here that wouldn't work? Well, no, you can square every number, and you can multiply every number by 3, and so there's no restrictions on what you can plug in for x. So a is just negative infinity to infinity. As we look at b, which is g of x is equal to 5x divided by x squared minus 49. That is a lot like the problem we just did as that bell ringer. So the first thing we need to do is factor our denominator. So how's x squared minus 49 going to factor? All right, so that is going to be difference of squares. We'll factor that as x plus 7, x minus 7. And so, because we can't have our denominator equal to 0, essentially what we're saying is that x cannot equal -7, because -7 plus 7 is 0, and x cannot equal +7, because 7 minus 7 is 0. But how would we write that then as a domain using our intervals? So if you're struggling to kind of think about that, what you can do is think of a number line and say, all right, well, I know x can't be +7, x can't be -7. So you can put an open dot on each of those. Remember, open dots means not equal to. And essentially, we're saying it can be every number but those two. So I can shade going this way, I can shade in between, I can shade going that way. So I'm just going to write an interval that shows everything but that -7 to 7. So our domain would essentially be, all right, it's going left forever, so negative infinity to -7. And notice I have a parenthesis. Because of that open dot, I have a parenthesis. It can't equal -7. I put that union symbol to link them together. Then from -7 to 7, but again, not equal to, so I have parentheses with both of them. And then I go from 7 to infinity. So again, because of those open dots, they're all parentheses, none of those are brackets. Just so you gotta take any notes here. All right, as we go on to letter C then, now we have a square root function. So you need to think to yourself, what kind of number can you not take the square root of and get a whole number out, or get a real number out at least? You can't take the square root of negative and get a real number out. Can you take the square root of 0? You can. Can you take the square root of positives? You can. So whenever we have a square root, what we're going to do is we're just going to take the radicand. Remember, the radicand is just what's underneath the square root. And we're going to say, all right, well, what's underneath there has to be greater than or equal to 0. So we just solve that inequality then. So I would add 27. And then divide by 9. So I get x is greater than or equal to 3. We do want to write that domain as an interval. So as long as our x value is larger than or equal to 3, it would work. So 3 is the smallest, and it can equal 3, so I have the bracket with the 3, and then it would go to infinity. And then for letter D, we have a square root in the bottom of a fraction. So for the square root part, we know it has to be greater than or equal to 0, but since that square root's in the bottom of the fraction, can it equal 0? No. So we're still going to take the radicand, what's underneath the square root, but now instead of it being greater than or equal to 0, we're just going to say, well, it has to be greater than 0. It can't be negative, and since it's on the bottom of the fraction, it can't be 0 either. So we're just saying greater than 0. So we would solve for x again, subtract 24, and then divide by negative 3. So because we divide by a negative, we would have to flip our sign. So we get x is less than 8. So thinking about that, what that would look like, that means the largest number it could be is really close to 8, but not actually equal to it. So I'd have an 8 on the right side with a parenthesis, and it would go left forever. So negative infinity to 8. But again, not including 8, because if it included 8, we'd have 0, square root of 0 on the bottom, and the square root of 0 is 0. We can't have 0 in the bottom of a fraction. So in general, if we're going to be doing this, finding the domains just by looking at the equations, our linears or quadratics, they have no restrictions ever. Okay, so if you have a linear, you have a quadratic, x squared, it's going to go from negative infinity to infinity always. If we have a radical equation, remember radical means the square root around it. We take the radicand, which is underneath the square root, and set that greater than or equal to 0. If we have a rational expressions are those fraction equations. So we have to factor the denominator, set each factor equal to 0, and then we find what it cannot equal. So with that example we just saw, we factored and saw that x can't be 7 or negative 7, and then we wrote our interval from there. And last, if we have a radical in the denominator, then we just set the radicand greater than 0. Okay, because it's in the denominator, it can't be equal 0. So that's the difference between the radical equations that we had in the second line versus the radical in the denominator. All right, then we have two other examples. So again, it's just find the domain here. So we have a rational equation for 30, and then we have radicals for 26. So we'll do 30 to start. So as we said in the previous, for these rationals, we have to factor our denominator first. What method do we use to factor something like that? Yeah, so we have to factor by grouping. Yep. So I'm going to first group these. Remember, if you do have a negative in front of that x, then you're just going to put a plus, and that negative should go inside the parentheses. All right, so I grouped it. Then we pull out a GCF within that grouping. So the first set of parentheses has a GCF of x squared. So when I divide each of these terms by x squared, I get x minus 2. My second grouping, my second parentheses within that has a GCF of negative 9, because remember we always want our x to have a positive coefficient, so I'm pulling out a negative 9, and when I divide each of these terms by negative 9, I get x minus 2. Remember, when you do factor by grouping, you want to get that x minus, or the same thing inside the parentheses. We have that. X minus 2 inside the first, x minus 2 inside the second. So once I have that, I can then pull out a GCF of x minus 2 from each term. So as I divide each of these terms by x minus 2 then to see what I have left, I'm left with x squared minus 9. All right, and what can I do with the x squared minus 9? I can factor that with difference of squares, yep. Okay, so that means my restrictions, when we set each of those equal to 0, the x cannot be 2, because 2 minus 2 is 0. It cannot be negative 3. Negative 3 plus 3 is 0. It cannot be positive 3. Positive 3 plus 3 is 0. So if you can make your intervals based off that, go right ahead. Sometimes when you have a bunch of them, it is a little bit easier to think of it as a number line. So you'd have an open dot at 3, an open dot at 2, an open dot at negative 3, and then you have shading at every place but those open dots. So again, you don't need to draw that number line, but sometimes it helps as you go through. So your domain would then be, it's going left forever, so from negative infinity to negative 3. Again, with a parenthesis because it's not equal to. We put our union, negative 3 to 2, our union, 2 to 3, and then it goes from 3 to infinity. So to me personally, that number line just kind of helps visualize where I'm starting and where I'm stopping. Again, you don't need that, but it does help. All right, and then our 26 has 2 radicals within it. Remember, when we said we have those radicals, what we're going to do is set that greater than or equal to 0. So since we have 2 of them, I'm just going to set each of them, for right now, greater than or equal to 0. These are not in the denominators of a fraction, so they can be equal to 0. So when I go and solve this, I will get x is greater than or equal to 3. X is greater than or equal to negative 4. So only one of these inequalities will satisfy both of them. So for it to satisfy this function, it has to satisfy both of them. So let's just think here. Since it can equal 3, I'm going to plug 3 into both equations, see if it works. 3 minus 3 is 0. Can I take the square root of 0? Yeah. If I plug 3 in, 3 plus 4 is 7. Square root of 7. It's not a perfect square, but I can take the square root of 7, right? If I plug negative 4 in, I'd have negative 4 minus 3, which is the square root of negative 7. Can I take the square root of negative 7? No. So this, although it would work for the second rational or radical equation, it wouldn't work for this first one. So we're not going to use this one. And we're just going to say, all right, that's going to be the inequality we're using because it works for both of them. And so as we go and do our domain, okay, 3 is the lowest we can do, and it can equal 3, and then it would go to infinity. All right, so I'll put up the homework then. 310, 1 to 9 odd, and 17 to 29 odd. All right, so again, it's page 310, 1 to 9 odd, and then 17 to 27 odd as well. Don't forget about the back of the book. The back of the book is there that you can check your work. Okay, that's why I assigned the odds.